All right, so we have learned two forms of a line, and today we're going to learn a third form of the line called standard form. We're also going to cover how to graph and find intercepts of a line. So let's start with standard form of a line. Standard form of a line is capital AX plus capital BY equals capital C. When you write something in standard form, A, B, and C must be whole numbers. So you might have to clear fractions or clear decimals to make that happen, but they cannot be fractional. Also, if you're going to write something in standard form, the A term has to be positive. The other two terms, B and C, can be negative, but A has to be positive. So to make that happen, you might have to multiply both sides by a -1 to make the A term positive like you want it. Now, as always, every form has something that it does well. Standard form is actually really good for story problems, but I think its biggest plus is you can use it for graphing with intercepts. And it's a really, really fast way to get your x-intercept and your y-intercept. So that's a big plus. One of the problems with standard form is like point slope form, there is no unique form. In other words, the equation can look an infinite number of ways. So there isn't like one right form. There's lots of them, and that can be kind of a pain. The other downside is that A, B, and C mean nothing. They are not slope. They are not the y-intercept. They're just three random numbers that are in the equation. So that's also kind of a pain, is the equation doesn't actually tell you anything about the line. All right, so let's do some examples of what you're going to be working with on your homework. Here's the first one. We're going to take the line y equals 2x plus 3, and we're going to write it in standard form. Okay, so if you look at standard form, A and B, the x and the y terms are on the left, the number term is on the right. So I'm okay with my y being on the left, but I do need to move my x term over to the left with it. So we're going to subtract 2x over to the left. So now I have -2x plus y equals 3. So the x is first, the y, the equal, and the number. Nicely enough, A, B, and C are whole numbers. That's good. But my A is not positive. So to fix that, we're going to need to multiply both sides of the equation by a -1. On the left, it gets distributed and it changes all the signs. Negative times a negative is a positive 2x. Negative times a positive is a -y. On the right, a positive times a negative is a -3. And that, my friends, is standard form. Whole numbers, the A is positive, you're good to go. All right, so that's how you get from slope-intercept form to standard form. So now we're going to go from point-slope form. So y minus a half equals -2 times x plus 1. And again, we're going to write it, I'm just going to abbreviate, in standard form. Okay, so standard form does not have any parentheses. So the first thing you should do is get rid of the parentheses. So you're going to distribute the -2, and that gives you -2x minus 2. So we've gotten rid of the parentheses. Now we need to move x and y left, numbers right. So I'm going to add 2x to move it to the left. So now I've got 2x plus y minus a half equals -2. Now I'm going to move the number to the right. So I'm going to add a half, add a half. So you got to put 2 over its invisible 1 and get a common denominator. So multiply by 2 over 2. So -4 plus 1 is -3/2. So I have 2x plus y equals -3/2. So on the good upside, my a and my b terms are whole numbers. That's nice. My a is positive. That's good. But my c term is a fraction, and you cannot have any fractions in this form. So what we're going to do is clear fractions. Now, we practiced this when we learned to solve, but you put all whole numbers over their invisible 1, and you multiply by the number it needs on the bottom to have a common denominator, and then you multiply by that bottom and top. So I need there to be a 2. So I multiply by 2, which means the top gets multiplied by 2. Same thing for the y. I need a 2 in the bottom, so I multiply by 2. That means I got to multiply the top by 2. So now I've got 4x over 2 plus 2y over 2 equals -3/2. I now have 2's on the bottom of everything. So now we're going to clear the 2's. And the reason this is legal is you're going to multiply both sides by 2 over 1, which will clear all the 2's out. And you're left with 4x plus 2y equals -3. So to recap on this one, we had to get rid of parentheses, move x and y left and numbers to the right. Then we needed to clear the fraction out by getting a common denominator and clearing it, just like you did when you were solving. Okay, let's go on to Roman numeral 2. We're going to talk about intercepts. Intercepts. Intercepts are where structures cross both axes. Okay, so I want you to draw a very tiny little graph, not very big, silver dollar size. All right, so we're going to draw a line on our little tiny graph. All right, and let's talk about intercepts. Okay, so the horizontal axis is the x-axis. So where your graph crosses the x-axis, that point is your x-intercept. Put an S on there. I don't know why. There we go. That's your x-intercept. Your x-intercept will always have the form some number a, comma 0, because it doesn't go up or down. The y coordinate is always 0 because it just goes left and right. To find the x-intercept, the process is you substitute in y equals 0, because y has to be 0 if it's an x-intercept, and solve for x. Substitute in y equals 0 and solve for x. All right, now we're going to talk about the y-intercept. The axis that goes up and down is the y-axis. So the place where your graph crosses that up and down line is called the y-intercept. Your y-intercept always has the form 0, comma, lowercase b. And you remember, lowercase b is from slope-intercept form. So yeah, 0 in the x, because it doesn't go left or right, it just goes up or down. So it only has a number in the y. So to find the y-intercept of your graph, you're going to substitute in x equals 0. and solve for y. So to get an intercept, basically you need to know where the 0 is, and you substitute the 0 in for x or y, depending on the one you're trying to find, and you solve for the other variable. It's actually a pretty easy process. All right, let's do an example. So you've got 2x minus 3y equals 6, and you're going to find the intercepts. Find the intercepts. Okay, so what you have to remember in your mental library is that the x-intercept always has the form a comma 0, which means y always equals 0. So that's what you're going to substitute in is y equals 0. So 2x minus 3 times 0 equals 6. And here's where standard form is actually pretty cool, because negative 3 times 0 is 0, and all you've got left is 2x equals 6, which is really easy. 2 times 3 is 6. So x must be 3, which means my intercept is 3, 0. You always, always, always list your 0 with your intercept. Even if your book key leaves just puts the 3 and doesn't put anything else, I want you to show it as a point, because you got to memorize where those zeros go. All right, so now that's our x-intercept. Now we're going to find our y-intercept. So in your mental library, a y-intercept is 0, b. And for the y-intercept, x is always 0. So that is what you're going to substitute in, is x equals 0. So let's do it. 2 times 0 minus 3y equals 6. 2 times 0 is 0. So you get negative 3y equals 6. And yes, negative 3 times 2 is 6. So y is negative 2, which means my y-intercept is 0, negative 2. 0 for the x, 2 for the y. All right, on part of your homework, you're just going to find the intercepts. That's it. Find the x, find the y, you're done. The second half is the graphing one. So we're going to go ahead and graph this same equation using intercepts. Now, we've already found the intercepts. So really, we just need to graph. So on the left-hand side, draw yourself a pair of axes. And we're going to plot our two intercepts on our axes. So 3, 0, so 1, 2, 3 to the right. And then 0, negative 2, down 2. And then draw your line. If your intercepts are whole numbers, then this is pretty easy to do. You just graph the two intercepts and you have a line. However, if your intercepts are fractional, you still have to plot them, but you need to add a replacement point. So if one of your intercepts is a fraction, you need to pick another x value and find another point. If both intercepts are fractional, that kind of sucks. You're going to have to then get 2 replacement points. If your intercepts are too close, they're just way tight in the center, you need to get another point. And it needs to be, something that's farther away that's going to give you a good graph. Because in the end, that's what we want, is a good graph, not just any graph. So if the intercepts are fractional, add a replacement point for each fraction. If they're way too close to get a decent line, get 1 more point and extend it out. On a test, you could even do 2 more points if you're really not sure about your line. Okay, any